Step number 1, import linear regression. Should be a comment. You've got to import these things. And the reason why is because Python is not cluttering up your space with libraries you don't need. There's so many libraries, right? So it's faster if you just import what you need. Okay, so this is like this. From sklearn dot linear model, okay? So it's kind of a library within a library. Import linear regression. There we go. We'll go ahead and press Shift Enter one cell at a time to make sure everything is working as expected. Okay, there we go. So now it's been imported. Next, number 2, we initialize linear regression model. Now, I think what I'm going to do, well, I'll just say linear regression. I'll come back to it later, actually. I was going to say these steps will be the same if you call them just like ML model. But let's, you'll see what I mean later. So model equals, and then you just call it out. So li, and there it is. It shows up, right? Because you imported it. And press enter. And you do need the parentheses. Okay. Go ahead and press Shift Enter. Now, you haven't done anything yet. You just like, you have linear regression. I mean, you could like mess around a little bit and be like, whoa, what if I, it's kind of fun to play with things like, wait, well, what if I just enter it right now? What happens if I press Shift Enter? And you can see like it shows you that, oh, model, hey, that's a linear regression function. And it's got some default parameters set up for you. Okay. Let's look at the type. That could be interesting. Should always be a type. sklearn.linearModel.base underscore base.linear regression. Okay. Okay, we don't need to do those things. Just showing you can play around with things and explore. Okay, what about number 3? This is it. This is the big line. Fit model to data. Okay, so here's how we do it. Here we go. This is the big one. I tried to explain in the slides what these actually do. By the way, when you press model dot, you see different methods associated with the linear regression model. So we're going to do fit, okay? And then in parentheses, it's x comma y. See, they're actually showing that in there. See how that's standard x comma y. Press Shift Enter. And you can see there it shows you again it shows you the model when you do that. But now the model has weights. Isn't it amazing? It's so fast. Like, it's almost deceptive. You've done it, okay? You just built a machine learning model, all right? I like saying this sometimes. Yes, it really is that easy. We don't know if it's any good, right? We don't know anything about it yet. We just know we built one. So let's try to do dot score x comma y. Get a scoring metric here. So number 4, I'm going to put in score the model. And it got 0.64, which isn't bad. You can almost think of it like correlation, kind of like the higher the better in some ways. I mean, it's not great. It's okay, right? So I have a lot to say about scoring metrics, and we'll look at them in the first half. But I do want to pause here because, in effect, those 4 steps, okay, are what you do to build a machine learning model. So I'm going to do it one more time. What are the 4 steps? I'll put another header in here. Steps all at once. Okay, you're going to get used to this. Number 1, import. Well, really, if it's loading the data, right? You've got to have the data first, right? So I mean, that's a preliminary step. But for the machine learning steps, we start with import model, okay? And that was here from sklearn.linear model, import linear regression. Okay. Number 2, initialize model. It's to be done. And in this case, that was model equals linear regression. Number 3, fit model to data. This is it, the big step. Model.fit x comma y. And finally, number 4, you always want to score the model because you've got to get something out of it. So one thing is getting a score. And this is done by model.score, although as we'll see, there are many different scoring metrics, and it's common for regression to actually use different scoring metrics. We'll talk about that later. Okay, and then if I run it like this, just go ahead and run that. Got a type error. Why did I get a type error here? Oh, .score. It's interesting. When I looked and I saw missing 2 positional arguments, x and y, and I looked up and I said, but wait, they're here. Well, what are you scoring? We're scoring, we're seeing how will what we're doing when we score it like this is we're seeing how will the model fit the data, okay? And there we go. It should give about the same result. Sometimes there's randomness involved. Looks like not for this case. We got the same result. So those are all the steps to building a machine learning model. It's 4 lines of code. And I do want to add in here, assuming that the data has been loaded and x and y have been defined, the following steps will work for a regression model. And there are different types of models. We'll look at classification tomorrow, okay? And then about the differences too. So, my congratulations. That is a machine learning model. Now, or next I should say, we're going to look at how you can use it to make predictions.